Hi everyone. This video is about basic sound theory as a starting point leading to music theory. So let's get started. Sound is a series of periodic variations in pressure transmitted through a media like air or water at an audible frequency. These variations in pressure are called sound pressure waves or sound waves. To produce sound waves, energy has to be applied to an object, starting a reaction that creates compression and rarefaction in the media that surrounds it. If the sound waves are produced by an acoustic instrument, they are transmitted in all directions within a three-dimensional space, similar to the way that lead particles travel outwards in a fireworks explosion. This way of travel is called omnidirectional. Sound waves have many different shapes, and four of the most common ones are sine, square, sawtooth, and complex. With a few exceptions, acoustic instruments produce only complex sound waves. Yet, most of the electronic instruments are able to produce all of the different kinds of sound waves. Even though sound travels in a three-dimensional space, the sound waves can be represented in two dimensions by using graphics. And when sound is recorded using a computer, the software usually provides visual aids with graphic representations of the recorded sounds that show the different shapes and cycles of sound waves. In these graphics, the vertical plane shows the volume and the horizontal plane shows the duration and pitch. In a relative way, the wider the wave, the louder it's going to sound, and the more narrow, the more quiet. Also, in the graphic we can see that the more cycles per second, the higher the pitch, and the less cycles per second, the lower the pitch. Let's hear two sound examples of sine waves and look at their graphics originated by a computer's sound recording software. If we compare them, we can see that the graphic of the sound with a lower pitch has less sound waves than the sound with the upper pitch in the same time length represented in vertical distance. For practical purposes, the sound wave cycles per second that we see in these graphics are expressed as units called hertz, and when used with numbers, these units indicate specific pitches. So, if the string of an instrument vibrates at a 440 Hz frequency, then the instrument is producing the note A4, provided that it's using conventional tuning. Besides volume, duration, and pitch, timbre is another property of sound. If two acoustic instruments of a different kind, like a violin and a trumpet, play the same note, the frequency produced by each of those notes is going to be the same. But the sound that each instrument produces is different because the timbre is different. And if we look at each of those sound waves, the shape will be different too. The reason why each acoustic instrument sounds different is because, in addition to the fundamental note produced by each one, with every note, instruments produce several simultaneous overtones that are more quiet and have a higher pitch. The pitch of those overtones is different for each instrument, and they react with the fundamental note, changing the shape of its sound wave, giving the instrument its particular timbre. The number of hertz in the overtones produced by pitched instruments is an integer multiple of that number in the fundamental. This means that if the fundamental note produces 110 hertz, the number of hertz is going to increase by 110 in each of the overtones, resulting in 220, 330, 440, 550 Hz, and so on. In theory, the number of overtones is infinite, but the human ear is only able to hear up to 20,000 Hz. Non-pitched acoustic instruments as drums, cymbals, or shakers do not have a single, but yet several simultaneous fundamental frequencies, producing even more complex waveforms than pitched acoustic instruments.